Now, in this lecture, we will answer on two questions. In the first question, we find out the side length of square ABCD, and in the second question, we will find out the length of line segment X. So we start with the first question. In the first question, we have in the drawing square ABCD. Inside the square we have this circle, and the radius of this circle is equal to 2 units. We also know that line segment DE, the short line segment DE is equal to 1 unit. And we want to find out the side length of square ABCD. Okay, so first of all we will define the side length of square ABCD as X. That is to say, AB equals to AD equals to CD equals to BC, and all the sides of square ABCD, they are equal to X according to our definition. So here the length of side AB is equal to X according to our definition. And we'll define the point of tendency of tangent AD with this circle as point M. We will define the center of this circle as point O. We will define the point of tendency of tangent AB with this circle as point L. And we will define the point of tendency of tangent EB with this circle as Z. So here OM is the radius of this circle that is equal to 2 units. So we define the radius of this circle as R, and R equals to 2 units. So here the radius OM of this circle, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we will join points O and L together by a straight line. So actually, line segment OL is the radius of the circle because of the fact that it starts from the center of the circle and ends at point L, that is the point of the circle itself. This is exactly the definition of a radius. So OL equals to R, that is equal to 2 units according to what's given us the question. So here we have the radius OL that is drawn to the point of tendency. That is to say, the radius OL, it is drawn to point L, that is the point of tendency of tangent MB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO. That is to say, this angle equals to 90 degrees. And this angle will be also equal to 90 degrees. Okay? Repeat again, this angle equals to 90 degrees and this angle equals also to 90 degrees. Okay? So, and we also know that all the angles inside the square are right angles. That is to say, angle BAD, it is a right angle. So, this angle equals to 90 degrees. So actually, in quadrilateral MOAL, we have 1, 2, 3 right angles. Again, in quadrilateral MOAL, we have 1, 2, 3 right angles. So in quadrilateral MOAL, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle MOL, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle MOL, is equal to 360 degrees minus 270 degrees, it is 90 degrees. So angle MOL, it is a right angle, equals to 90 degrees. So here this angle equals to 90 degrees. So actually, we found out that all 4 angles inside quadrilateral MOAL are right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MOAL as a rectangle. Quadrilateral MOAL is a rectangle. And we know that the opposite sides of a rectangle are equal to each other, so a rectangle MOAL, MO must be equal to AL. MO must be equal to AL according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that MO equals to 2 units, so we can write here that MO equals to 2 units. And from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, an rectangle MOAL OL must be equal to MA. OL equals to MA according to the rule that the opposite sides of a rectangle are equal to each other. Okay, OL equals to MA. But we've already found out that OL equals to 2 units. So I can write here that OL equals to 2 units. And from this equation, 2 equals to OL equals to MA, we will derive that MA is also equals to 2 units. MA is also equals to 2 units. Here, MA equals to 2 units, so all the sides of quadrilateral MOAN, they are equal to each other, they are equal to 2 units. Therefore, quadrilateral MOAN is not a rectangle but a square. Okay, write it down. I'm sure you found out that quadrilateral MOAN is a square. Okay. In the next step, I will present to you a new rule that will be rule number 2 according to, it is not a new rule because I have already mentioned it, so I'll repeat on the rule that will be called rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So here we will implement rule number 2 in our drawing. Here we have the common external point, point E. From the common external point, point E, we actually have two tangents to this circle. From the common external point, point E, we have two tangents to this circle. The first tangent is tangent EM, and the second tangent is tangent EZ. And according to rule number 2, EM must be equal to EZ. I'll repeat again. We have two tangents from a common external point, point E, to the circle, EM and EZ. That according to rule number 2, EM must be equal to EZ. Why? Because both those two tangents are exiting from the same point, point E to that circle, therefore their lengths must be equal to each other. That is to say, EM equals to EZ according to rule number 2. Okay? EM equals to EZ. What is the length of EM? What is the length of line segment EM? From the drawing, it is very easy to see that the length of line segment EM, it is equal to dA. That is the sine length of square ABCD. It is dA minus dE minus MA. I will repeat again. From the drawing, it is very easy to see that EM equals to dA minus dE minus MA. So actually, EM equals to dA, but dA equals to x according to our definition, so we substitute dA by x. minus d equals to 1 unit according to what is given as the question, so we'll substitute d by 1 minus ma equals to 2 units according to what we have already found out. So in conclusion, we found out that em equals to x minus 1 minus 2, so em equals to x minus 1 minus 2 is minus 3. So em equals to x minus 3 you can write here that em equals to x minus 3 but according to rule number 2 we have already found out that em equals to ez from one side, and from the other side we just right now found out that em equals to x minus 3, so we can write here that em equals to x minus 3, and from this equation x minus 3 equals to em equals to ez, we will derive that ez is also equals to x minus 3. Ez is also equals to x minus 3. So we can write in the drawing that ez equals to x minus 3, this line segment equals to x minus 3. In the next step we will focus on the common external point B. From the common external point B we have two tangents to this circle. The first tangent to this circle from the common external point B is BL. The point of tendency of tangent BL with this circle is L. And the second tangent to this circle from point B is BZ. Z is the point of tendency of the second tangent with this circle. And according to rule number 2, BL equals to BZ. BL equals to BZ according to rule number 2. What is the length of BL? From the drawing it is very easy to see that the length of BL, if BL, it is equal to AB minus AL. Again, AB minus AL equals to BL. AB minus AL. I'll repeat again. Yeah. From the drawing it is very easy to see that BL equals to AB minus AL. Okay. So actually BL equals to AB equals to x according to our definition, minus AL. We have already found out that AL equals to 2, so we substitute AL by 2. So in conclusion, we found out that BL equals to x minus 2. BL equals to x minus 2, so we can write here that BL equals to x minus 2. But according to rule number 2, we have already found out that BL equals to BZ. So from one side BL equals to BZ. From the other side we just right now found out that BL equals to x minus 2. So from this equation x minus 2 equals to BL equals to BZ, we will derive that BZ is also equals to x minus 2. BZ is also equals to x minus 2. So we can write here that BZ equals to x minus 2. In the next step we find out the length of line segment AE. Here the length of line segment AE from the drawing, it is very easy to see that AE equals to AD minus DE. Again, AD minus DE equals to AE. I will repeat again. From the drawing, it is very easy to see that AE equals to AD minus DE. So AE equals to AD, that is x, according to our definition, minus DE, that is equal to 1, according to what is given as the question. So in conclusion, we found out that AE equals to x minus 1. So in the next step, I will copy the right triangle AEB in this page, and we will implement the Pythagoras theorem on this triangle AEB. Okay. So we just right now found out that A equals to x minus 1, and we've already found out that AB equals to x actually according to our definition. What is the length of the hypotenuse EB? From the drawing, it is very easy to see that the length of the hypotenuse EB, or triangle AEB, it is equal actually to x minus 3 plus x minus 2. I repeat again, the hypotenuse EB of this triangle AEB, equals to x minus 3 plus x minus 2, that is to say, EB equals to x plus x is 2x, minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB of this triangle AEB equals to 2x minus 5 units. So now we will implement the Pythagoras theorem on this right triangle AEB. Okay? So here, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AE squared plus AB squared. Okay? So according to the Pythagoras theorem, we get that AB squared equals to AE squared plus AB squared in the right triangle AEB. EB the hypotenuse EB equals to 2x minus 5. We substitute EB by 2x minus 5. If EB equals to 2x minus 5, then EB squared will be equal to 2x minus 5 squared, and it is equal to AE squared. AE equals to x. Therefore, A squared will be equal to x squared plus A. Okay. AB squared plus AE squared. So here AE equals to x minus 1. If A equals to x minus 1, it means that AE squared will be equal to x minus 1 squared. So according to equation number 1, we actually found out that 2x minus 5 squared equals to x squared plus x minus 1 squared. Here we will open the brackets on both sides of this equation, equation number 1, according to the algebraic identity that A minus B squared equals to A squared plus B squared minus 2 times AB. And we get here that 2x minus 5 squared will be equal to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times x times 5. 2 times 2x times 5. So 2 times 2x is 4x, and 4x times minus 5 is minus 20x. And it is equal to x squared plus x minus 1 squared. So x minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2x. Okay, so here, so in this side of equation number 1, we have 4x squared minus 20x plus 25, and in the other side of equation number 1, we have x squared plus x squared is 2x squared minus 2x plus 1. Here we subtract 2x squared from this equation, equation number 1. 2x squared minus 2x squared is 0, and 4x squared minus 2x squared is 2x squared. We will add 2x to this equation, equation number 1. 2x minus 2x is 0. Minus 20x plus 2x is minus 18x. And finally, we will subtract 1 from this equation, equation number 1. 1 minus 1 is 0. 25 minus 1 is 24. That is equal to 0. So here we will divide this equation, equation number 1 by 2. And we get that according to equation number 1, 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, plus 24 over 2 is plus 12, and 0 over 2 is 0. So actually, we got the quadratic equation that x squared minus 9x plus 2f equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So we will put the data inside this equation, and we will find out the value of the values of x. So, and we will get here that x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared, b equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c is 12. So it is minus 4 times 12 over 2a. A is 1, so 2 times 1 is 2. So actually found out here that x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So actually found out that x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2, it is equal to 1.62 units. So we actually found out that x equals to 1.62 units. Okay, x equals to 1.62 units according to the first solution. So here, AB, it is equal to x. So the side length of square ABCD, that is AB, equals to 1.62 units. But from the drawing you can see that AL itself equals to 2 units. AL equals to 2 units. And AB, that is equal to x, it is greater than AL. So if AB is greater than AL, and AB equals to x, it means that x is greater than 2. Okay? Here, x, that is equal to AB, it is greater than AL, that is equal to 2. So AB, from this equation, x equals to AB equals to x equals to AB, and AB is greater than AL, that is equal to 2. We will derive that x is greater than 2 units. Okay? X is greater than 2 units, and the solution x that is equal to 1.62, it is less than 10 units. X that is equal to 1.62 is less than 2 units. And x must be greater than 2 units. Therefore, this solution is incorrect solution. We cancel this solution. From the drawing you can see that x must be greater than 2 units because it is greater than AL. It is greater than AL, and AL itself equals to 2. So x is greater than 2. So x is greater than 2, therefore x can never be equal to 1.62 units, that is less than 2 units. So we cancel the solution, and we left only with the second solution for x, that x equals to 9 plus square root of 33 over 2 units. That is the solution to the question, that x equals to 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. Okay? So here, the side length of square ABCD equals to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. We finished with the first question. In the next step, I will present to you the second question, and we'll solve the second question in two different methods. Okay? In the second question, we have triangle ABC. We know that line segment BD equals to 2 units, side AB equals to A units, side AC equals to 2A units, angle BAD equals to 60 degrees, angle DAC also equals to 60 degrees, and we want to find out the length of side AD that is equal to X. Okay? So, first of all, I will present to you a new rule that is actually the angle bisector theorem. It is a rule that I presented to you in the past, so I'll return and repeat on it quickly. So what is angle bisector theorem? Angle bisector theorem is true in any triangle So if we have triangle ABC, that could be any triangle. This is triangle ABC. And we also have here line segment AD that is defined as angle bisector. AD is angle bisector. Why line segment AD is angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. Therefore, AD is defined as angle bisector. So, the reason that we can implement the angle bisector theorem in this triangle is because we have here the angle bisector AD. Okay? And a triangle ABC could be any triangle. So according to angle bisector theorem, we'll get that AB over AC equals to BD over DC. I will repeat again, according to angle bisector theorem, if we have triangle ABC that could be any triangle, here AD is angle bisector because of the fact that it divides angle BAC into two halves, each half equals to theta. Therefore, according to angle bisector theorem, in this triangle that we have the angle bisector AD, the following equation is true, that AB over AC equals to BD over DC. We will implement angle bisector theorem in our triangle ABC. I repeat again that the reason that we can implement angle bisector theorem in this triangle ABC is because of the fact that we have here AD, line segment AD that is equal to X, It is angle bisector in triangle ABC. Why? Because it divides angle BAC into two halves. Each half equals to 60 degrees. Only for that reason we can implement the angle bisector theorem in triangle ABC. That only because of the fact that we have here the angle bisector AD. So in triangle ABC, according to the angle bisector theorem, we'll get that AB over AC equals to BD over DC. I'll write here that AD is angle bisector. I repeat again, in triangle ABC, our triangle, we have AD that is angle bisector. Therefore, we can implement the angle bisector theorem in triangle ABC. According to angle bisector theorem, we get that AB over AC equals to BD over DC. AB equals to A according to what is given as the question, so we substitute AB by A over AC. AC equals to 2A according to what is given as the question, so we substitute AC by 2A. BD equals to 2 units according to what is given as the question, so we substitute BD by 2. Over DC. DC is the missing line segment. So we leave it as it is. So in conclusion, according to question number 1, we got that A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled. So in this side of the equation, we left only with 1 half. According to question number 1, 1 half equals to 2 over DC. Here we will cross multiply this equation number 1, and we get that DC equals to 2 times 2. That is to say, DC equals to 4. We found out that DC equals to 4 units. So we can write down here that DC equals to 4 units. In the next step, we'll do a construction. We will extend side CA by a straight line. I repeat again, we will extend side CA of triangle ABC by a straight line. And from point B, we will raise perpendicular to the extended CA. I repeat again, from point B, we will raise perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. Okay? We define the touching point of the extended CA and the perpendicular from point B as E. So I repeat again that angle BEA equals to 90 degrees according to our construction. I write it down here. Angle BEA equals to 90 degrees according to our construction. CA is one side of triangle ABC, and CA is a side of a triangle. It is absolutely a straight line. So CA is a straight line. Then we actually extended the straight line CA by straight line. And in this way we got line segment CE. When you extend a straight line by a straight line, the result must be also a straight line. That is to say, CE is also a straight line. So CE is a straight line because when you extend a straight line by a straight line, the result must be a straight line. CE is a straight line. So we'll focus on the lower side of the straight line CE at point A. On the lower side of the straight line CE at point A, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So, in the lower side of the straight line C at point A, the sum of the angles must be equal to 180 degrees. So, which angles we have at the lower side of C at point A? We have here 60 degrees plus 60 degrees plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I'll repeat again. In the lower side of the straight line C at point A, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. That is to say 60 degrees plus 60 degrees plus angle EAB must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees. Plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 120 degrees from this equation, and we will get that the missing angle EAB, equals to 180 degrees minus 120 degrees, it is 60 degrees. So I found out here that the missing angle EAB equals to 60 degrees. So in the next step we will focus on the right triangle, triangle EAB. On the right triangle, triangle EAB. On the right triangle, triangle EAB. We know that cosine 60 degrees equals to EA over AB. I repeat again. On the right, the green triangle, triangle EAB, cosine 60 degrees equals to EA over AB. So cosine 60 degrees equals to EA over AB, but AB equals to A according to what's given in the question. So we substitute AB by A. We know that cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and we get that 1/2 equals to EA over A. Here we will multiply This is a question by A. And we will get that EA equals to A over 2. EA equals to A over 2. So I found out here that EA equals to A over 2. We will continue to focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB. We know that sinus 60 degrees equals to, here, sinus 60 degrees equals to EB over BA. EB over BA. So it is equal to EB, and BA equals to A according to what is given as the question. So we substitute BA by A. And we know that sinus 60 degrees is square root of 3 over 2, so we'll substitute sinus 60 degrees by square root of 3 over 2. And it is equal to EB over A. Here we will multiply this equation by A, and we get that, in conclusion, EB equals to A times square root of 3 over 2 units. So here EB equals to A times square root of 3 over 2 units. In the next step, we will focus on the big right triangle, triangle EBC, and we will implement the Pythagoras theorem on the big right triangle, triangle EBC. So I'll copy the right triangle EBC in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle EBC. Okay? In this way, we'll find out the value of A, of course, because A is the only missing variable. Here we have already found out that EB equals to square root of 3 over 2 times A. The hypotenuse BC equals to 2 plus 4, that is 6. EC, what is the length of side EC? It is very easy to see from the drawing that EC, side EC equals to 2A plus A over 2. 2A plus A over 2 equals to 2.5A. And 2.5A is 5 over 2A. So EC, in conclusion, EC equals to 5 over 2A, that is actually 2.5A. So here in triangle EBC, by PT is the operation for Pythagoras theorem, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? This will be question number 2. the hypotenuse is BC. Therefore, the square of the hypotenuse is BC squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to EB squared plus EC squared. BC equals to 6, so BC squared is 6 squared, that is 36. And it is equal to EB squared. EB is square root of 3 over 2 times A, of course. So EB squared is square root of 3 over 2 times A squared plus EC squared. EC equals to 5 halves times A. Therefore, EC squared will be equal to 5 halves A squared. Here we will open the brackets on this side of the equation number 2. On this side of equation number 2 we have 36 equals to square root of 3 square is 3, 2 square is 4 times A squared plus 5 square is 25 over 2 square is 4 times A squared. So according to equation number 2, we actually found out that 36 equals to 3 quarters plus 25 quarters is 28 quarters times A squared, of course. 28 over 4 is 7, so I write it down. So we actually found out that according to equation number 2, 36 equals to 28 over 7 is 7, A squared. Here we will divide this equation number 2 by 7, and we will get that according to equation number 2, A squared equals to 36 over 7. A squared equals to 36 over 7. Here we'll take a root out of this equation number 2, and we'll get that according to equation number 2, A equals to square root of 36 is 6 over square root of 7. So in conclusion, we found out that the value of A equals to 6 over square root of 7 units. Okay. In the next step, I will present to you a new rule, that is rule number 3, that is also connected to angle bisector. Okay, so we'll have here in the first method 2 different rules that are related to the angle bisector in triangle. This will be rule number 3. So here we have triangle ABC that could be any triangle. And of course in this triangle ABC, we have to have angle bisector. We can implement any rule that is related to the angle bisector only and only if we have in the triangle angle bisector. Otherwise, we not use any rule that is related to angle bisector if we don't have the angle bisector in the triangle. So if in triangle ABC we have the angle bisector AD, I repeat again that angle AD is angle bisector because of the fact that it divides angle BAC into two halves. Each half equals to theta. So, and according to rule number 2, to rule number 3, the following equation is true. If we have triangle ABC, that could be any triangle, we have in triangle ABC the angle bisector AD. According to rule number 3, we'll get that AD squared equals to AB times AC minus BD times DC. I'll repeat again. According to rule number 3, we have triangle ABC that could be in a triangle. When we have in triangle ABC the angle bisector AD, then AD squared equals to AB times AC minus BD times DC. We will implement the angle bisector theorem in triangle ABC. Again, we can implement the angle bisector theorem in triangle ABC only and only because of the fact that we have AD, side AD, that is angle bisector in triangle ABC. So in triangle ABC, I'll copy triangle ABC in the new page, and in this page, and we will implement the rule number 3 in triangle ABC. Angle BAC equals to 60 plus 60, this is 120 degrees. Side AB of triangle ABC equals to A units. Side AC equals to 2A units. And here we have the angle bisector AD. That is equal to x according to what is given in the question. We know that BD equals to 2 units, and we already found out that DC equals to 4 units. So in this triangle ABC, here AD is angle bisector, and for that reason we can implement rule number 3 in triangle ABC. Otherwise, we cannot implement rule that is connected to angle bisector without the angle bisector itself. AD is angle bisector. Therefore, we will get that according to rule number 3 here, this will be question number 3. AD squared equals to AB times AC minus BD times DC. Again, according to rule number 3, AD squared equals to AB times AC minus BD times DC. AD equals to x according to what is given in the question, so AD squared will be equal to x squared. That is equal to AB times AC. AB equals to A, AC equals to 2A, minus BD. BD equals to 2, DC equals to 4. So minus 2 times 4 is minus 8. So here we actually found out that x squared equals to 2a squared minus 8. But we have already found out that a squared equals to 36 over 7, so we substitute a squared by 36 over 7 minus 8. So actually we found out that the going into equation number 3, x squared equals to 2 times 36 is 72 over 7. Here we multiply minus 8 by 7 and then we divide it by 7 in order to have a common factor with this expression. Minus 8 times 7 is minus 56. So actually, in conclusion, we found out that x squared equals to 72 minus 56 is 16 over 7. So x squared equals to 16 over 7. Here we'll take a root out of this equation, equation number 3, and we will get that x equals to the square root of 16, that is 4, over square root of 7. So in conclusion, we found out that x, the line segment that we are looking for in this question, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, so here we can write down that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. We finished with the first method. In the next step, we will present to you how to find out the length of line segment x according to the second method. Okay? In the second method, we will define angle ADB as theta. BC is a straight line because BC is one side of triangle ABC. BC is a straight. BC is a side of a triangle, must be a straight line. Okay, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. That is to say, here we have here angle, which angles we have at point D, and the upper side of BC we have here angle theta, and we have angle ADC. The sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So if angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta will be equal to 180 degrees, exactly according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, the sum of the angles of the upper side of the straight line BC at point D will be equal to 180 degrees. Okay, so in the next step, I will present to you the law of sines. the log sines into in a triangle. So if you have triangle ABC, that could be any triangle. We know that the length of side BC is equal to A units, the length of side AB equals to C units, and the length of side AC equals to B units. Then according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. Here capital A, capital B, and capital C are the sizes of angles. Capital A is the size of angle BAC. Capital B is the size of angle ABC, and capital C is the size of this angle, angle BCA. So in any triangle, A over sine A equals to B over sine B equals to C over sine C. We actually can implement the law of sines in our drawing. Here we will implement the law of sines in triangle ABD. In triangle ABD, according to the law of sines, this triangle ABD, we will get that A over sinus theta equals to 2 over sinus 60 degrees. Again, A over sinus theta equals to 2 over sinus 60 degrees. And we will implement the law of sines also in triangle ADC. In triangle ADC, according to the law of sines, we will get that, this will be equation number 2, we will get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Repeat again. 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. That is to say, we can substitute sinus 180 degrees minus theta in this equation, equation number 2, by sinus theta. We'll do it now, and we will get that according to equation number 2, 2A over sinus theta equals to DC over sinus 60 degrees. According to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees. That is to say, we can substitute A over sinus theta in this equation, equation number 2, by 2 over sinus 60 degrees from equation number 1. We will do it now, and we'll get that according to equation number 2, 2 times A over sinus theta. A over sinus theta equals to 2 over sinus 60 degrees. And it is equal to DC over sinus 60 degrees. Here we have sine of 60 degrees on both sides of the equation, so sine of 60 degrees will get cancelled. And what is left from equation number 2 after we cancelled sine of 60 degrees? What is left is actually, here we have only the equation number 2, we get that 2 times 2 equals to DC. So actually DC equals to 2 times 2, that is 4. Found out that DC equals to 4 units, exactly as we found out in the first method. So here DC equals to 4 units. In the next step we will implement the law of cosines in triangle BAC. What is the law of cosines? I will repeat on it quickly. If we have triangle ABC, this is the law of cosines. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. The length of side AB is equal to A units. The length of side AC equals to B units, and the length of side BC equals to C units. Then according to the law of cosines, we get that cosine theta equals to A square plus B square minus C square over 2 times AB. I repeat again, in triangle ABC that could be any triangle, side AB equals to A units, side AC equals to B units, and side BC equals to C units, and angle B is equals to theta. Then according to the law of cosines, we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. We will implement the law of cosines in triangle ABC. Here, so I'll copy triangle ABC in this page and we implement the law of cosines in triangle ABC. Here angle BAC equals to 60 degrees plus 60 degrees, that is 120 degrees. Side AB equals to A units according to what is given as the question. Side AC equals to 2A. Side BC equals to 2 plus 4, that is 6. So this is triangle ABC. Here the implementation of the law of cosines in this triangle ABC is, this will be question number 3, cosine 120 degrees equals to AB square is A square, plus AC square is 2A square, that is 4A square, minus C square, that is BC square. BC square is 6 square, that is 36, over 2 times AB is A, and AC is 2A. Okay, so here cosine 120 degrees equals to minus 1/2. That is equal to A square plus 4A square is 5A square, minus 36 over 2A times 2A. Here we divide, we have 2 on both sides of the equation, so we'll divide this equation by 2, so we'll get cancelled. and we'll cross multiply this equation, and we get that here a squared times 2a is 2a squared. 2a squared minus 1 is minus 2a squared. That is equal to 5a squared minus 36. Here we will add to this equation 2a squared, and we will also add 36 simultaneously, and we get that according to equation number 2, according to equation number 3, 5a squared plus 2a squared is 7a squared. So 7a squared equals to 36. We divide this equation number 3 by 7, and we get that according to equation number 3, a squared equals to 36 over 7. Here we'll take out of this equation number 3, and we get that a equals to the square root of 36, that is 6, over square root of 7. So I found out the value of a. In the next step, I will present to you a new formula to find out the area of any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. The length of side AB is equal to A units, the length of side AC equals to B units. Then according to the new formula, the area of this triangle ABC, will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We will implement this new formula in our drawing. It is very easy to see that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ABC. Again, the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So we write it down. The area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. And the area of triangle ABC, according to the new formula that I presented to you, the area of triangle ABC will be equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees, so it is sine 120 degrees over 2. So we actually found out that the area of triangle ABC according to the new formula equals to A times 2A times sinus 120 degrees over 2. Likewise, the area of triangle ABD according to the new formula will be equal to A times X times sinus 60 degrees over 2. Again, 8 times x times sinus 60 degrees over 2. Here, the area of triangle ABD equals to A times x times sinus 60 degrees over 2 plus the area of triangle ADC. It is equal to x times 2A times sinus 60 degrees over 2. I'll repeat again, the area of triangle ADC equals to x times 2A times sinus 60 degrees over 2. Here, the area of triangle ADC equals to x times 2A times sinus 60 degrees over 2. So here we have 2 on both sides of the equation, so 2 will get cancelled. we have a on both sides of the equation, so a will also get cancelled. And we know that sinus 120 degrees equals to sinus 60 degrees, so sinus 60 degrees will also get cancelled. And what is left after we cancel all those variables? What is left is that in this side of the equation we have 2a that is equal to x plus 2x. So 2a equals to x plus 2x. So 2a equals to x plus 2x, that is 3x. Here we'll divide this equation by 3 and we'll get that x equals to 2 over 3 times a. X equals to 2 over 3 times a. But we have already found out that a equals to 6 over square root of 7, so we substitute a by 6 over square root of 7, and we get that x equals to, here we have 6 over 3 is 2, so it is 2 times 2 over square root of 7. 2 times 2 is 4 over square root of 7. So in conclusion, found out that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, we finish with the second method. In the next step, I will summarize the lecture, and we will start with the first question. Here in the drawing we have a square ABCD. We know that line segment D equals to 1 unit. The radius of this circle is equal to 2 units. And we want to find out the side length of square ABCD. Okay, so here we have here the radius OM of the circle. It is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will also equal to 90 degrees. Then from point, we join points O and L together by a straight line. OL is the radius of this circle, because it starts from the center of the circle and ends at point L, that is the point on the circle itself. So here we have the radius OL that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this radius. Tangent AB with the circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. And we know that all the angles inside the square are right angles, that is to say angle BAD must be equal to 90 degrees. So in quadrilateral MOAL, we have 1, 2, 3 right angles. Okay, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract the 270 degrees from this equation, and found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is 90 degrees. So this angle equals to 90 degrees. Therefore, in quadrilateral MOAL, we have 4 right angles. And any quadrilateral that has 4 right angles must be a rectangle. So we relate to quadrilateral MOAL as a rectangle. Okay, but before that we actually define the side of square ABCD as x. That is to say, AB equals to AD equals to CD equals to BC equals to x, according to our definition. Okay, so we know that the quadrilateral MOAL is a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO must be equal to AL, MO must be equal to AL, but MO equals to 2 units according to what we have already found out. So here MO equals to 2 units, and from this equation 2 equals to MO equals to AL, 2 equals to MO equals to AL, we derive that AL is also equals to 2 units. Here AL equals to 2 units also. Okay, likewise, MA must be equal to OL. Here MA must be equal to OL, according to the rule that the opposite sides of a rectangle are equal to each other, but OL equals to 2 units according to what we have already found out. OL equals to 2 units, and from this equation 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. So all the sides of quadrilateral MOAL are equal to each other. Therefore, quadrilateral MOAL is not a rectangle but a square. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point E. From the common external point, point E, we have two tangents to this circle, tangent EM and tangent EZ. And according to rule number 2, they are equal to each other. EM equals to EZ, according to rule number 2. So, what is the length of line segment EM? From the drawing it is very easy to see that EM equals to DA minus DE minus MA. EM equals to DA minus DE minus MA. So EM equals to DA, that is x according to our definition, minus DE, that is 1 according to what is given in the question, minus MA, that is equal to 2 units according to what we have already found out. So in conclusion, we found out that EM equals to x minus 1 minus 2. So x minus 1 minus 2 equals to x minus 3. So we found out that EM equals to x minus 3. So from one side, EM equals to EZ according to rule number 2. But from the other side, we just right now found out that EM equals to x minus 3. So we can write here that EM equals to x minus 3. And from this equation, x minus 3 equals to EM equals to EZ, we derive that EZ is also equals to x minus 3. EZ is also equals to x minus 3. Then we focused on the common external point, point B. From the common external point, point B, we have two tangents to this circle, tangent BL and tangent BZ. And according to rule number 2, they are equal to each other. That is to say, BL equals to BZ, according to rule number 2. BL equals to BZ, according to rule number 2. What is the length of BL? It is very easy to see from the drawing that BL it is equal to AB minus AL. Again, AB minus AL equals to BL. Here BL equals to AB minus AL. AB equals to X. AL equals to 2 units. In conclusion, found out that BL equals to X minus 2. BL equals to X minus 2. Here BL equals to X minus 2. But according to rule number 2, BL equals to BZ. We just right now found out that BL equals to X minus 2. And from this equation, X minus 2 equals to BL equals to BZ, we derive that BZ is also equals to X minus 2. Here, BZ equals to X minus 2. And then we found out the length of line segment EA. From the drawing it is very easy to see that the length of line segment EA is equal to AD minus DE. A equals to AD minus DE, AD equals to X, D equals to 1 unit according to what is given as the question. So in conclusion, we found out that and the length of line segment EA is x minus 1. We have already found out that AB equals to x according to our definition. Here the hypotenuse EA equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2. The hypotenuse EB equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2 is x plus x is 2x. Minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2x minus 5. Then we implemented the Pythagoras theorem on this right triangle, triangle AB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, EB square equals to EA square plus AB square. Then we know that EB equals to 2x minus 5, so EB square is 2x minus 5. AB equals to x, so AB square is x squared. A equals to x minus 1, so A square is x minus 1 squared. We open the brackets on both sides of this equation number 1. 2x minus 5 squared is 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5 is minus 20x, that is equal to x minus 1 squared. It is x squared. X minus 1 squared is x squared, plus 1 squared, that is 1, minus 2x. So in this side of equation number 1, we have 4x squared minus 20x plus 25. And the other side of equation number 1, we have x squared plus 2, x squared plus x squared is 2x squared minus 2x plus 1. So here we subtracted 2x squared from this equation number 1. So 2x squared minus 2x squared is 0, and 4x squared minus 2x squared is 2x squared. Then we added 2x to this equation number 1. Minus 2x plus 2x is 0, and minus 20x plus 2x is minus 18x. So, and here we have 25 and 1, so we subtract 1 from this equation number 1. 1 minus 1 is 0, and 25 minus 1 is 24. So in conclusion, we found out that 2x minus 18, 2x squared minus 18x plus 24 equals to 0. We divided this equation by 2, and we got that 2x squared minus 18x plus 24 equals to x squared minus 9x plus 12, that is equal to 0. So here we have the quadratic equation. In this quadratic equation, a equals to 1, b equals to minus 9, and c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So here x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared. B is 9, b is minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, and c is 12, so it is minus 4 times 12 over 2a. A is 1, so 2 times 1 is 1. So here we got that x equals to 9 plus minus 81, and minus 4 times 12 is minus 48 over 2, so x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to 9 minus 4 to 33 over 2, that is equal to 1.62 units. So according to the first solution, we found out that the side depth of quadrilateral ABCD, that is equal to x, according to our definition, it is equals to 1.62 units. Here, so here AB that is equal to x, it is equal to 1.62 units. But here AL equals to 2 units. And x, it is greater than AL. See here that x it is greater than AL, that is equal to 2 units. So if X is greater than AL, that is equal to 2 units, it means that X is greater than 2 units. If X is greater than 2 units. And 1.62 is less than 2 units, therefore, so we know that X must be greater than 2 units from one side, and the answer is that X, it is equal to 1.62, that is less than 10 units, that is less than 2 units. Okay, so therefore this solution is incorrect solution because of the fact that X must be greater than 2 units. And X that is equal to 1.62 is less than 2 units. Less than 2 units, so we cancel this solution and we left only with the second solution, that X equals to 9 plus root of 33 over 2. This is the answer to the question, or in terms of numbers it is equal to 7.37 units. So finish with the first question. Then I presented to you how to find out the length of line segment X in 2 different methods. This is actually the second question. The second question we have here triangle ABC. We know that BD equals to 2 units, AB equals to A, AC equals to 2A, angle BAD equals to 60 degrees, angle DAC equals to 60 degrees also, and we want to find out the length of line segment AD that is equal to X. So first of all, I presented to you the angle bisector theorem. So if triangle ABC, and triangle ABC could be any triangle, can be any triangle. In triangle ABC we have angle bisector AD. Why AD is angle bisector? Because it divides angle BAC into 2 halves. Each half equals to theta. So in this we have here the angle bisector AD. Therefore we can implement the angle bisector theorem here. According to the angle bisector theorem, the following equation is true, that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. We implemented the angle bisector theorem in this triangle, triangle ABC. We can implement the angle bisector theorem in triangle ADC because we have AD, that is the angle bisector of angle BAC, divided into 2 halves. Each half equals to 60 degrees. Therefore, according to the angle bisector theorem, we get that AB over AC equals to BD over DC. In triangle ABC, AB equals to A, AC equals to 2A, BD equals to 2, and DC is the missing line segment. Here A over A is 1, so A will get cancelled, and this side of the question number 1, we left only with 1 half, that is equals to 2 over DC. We cross multiply this equation number 1, and we found out that DC equals to 2 times 2, that is 4. So DC equals to 4 units. Then I presented to you, actually here we did a construction. We did here a construction. We did a construction here. We extended side AC by a straight line, and from point B we raised perpendicular to the extended CA. That is to say, this angle equals to 90 degrees according to our construction, and we find the touching point of the extended CA and the perpendicular from point B is E. And here we extended the straight line CA by a straight line and we got CE. Therefore, CE must be a straight line, because when you extend a straight line by straight line, the result must be a straight line. So we know that CE is a straight line, and if you focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have at the lower side of the certain CE at point A? We have 60 degrees plus 60 degrees and angle EAB. Here 60 degrees plus 60 degrees and angle EAB. In total, the sum of those three angles must be equal to 180 degrees. Okay, so 60 degrees plus 60 degrees is 120 degrees plus angle EAB equals to 180 degrees. We subtracted 120 degrees from this equation and we got that the missing angle EAB, this angle equals to 60 degrees. Okay, so in this right great triangle EAB, we know that cosine 60 degrees equals to EA over AB. Cosine 60 degrees equals to EA over AB. So it is EA over AB. AB equals to A, so we substitute AB by A. And we got that cosine 60 degrees is 1/2. So we substitute cosine 60 degrees by 1/2. And we got that 1/2 equals to EA over A. We multiply this equation by A. And found out that EA equals to A over 2. Here EA equals to A over 2. Then in this green right triangle, we know that sine of 60 degrees equals to EB over BA. Sine of 60 degrees equals to EB over BA. So it is equals to EB over BA, and BA is A. So sine of 60 degrees equals to B over A. We know that sine of 60 degrees is equal to 3 over 2, so we got that sine of square root of 3 over 2 equals to EB over A. We multiply this equation by A, and we found out that EB equals to square root of 3 over 2 times A. Here, sine EB equals to square root of 3 over 2 times A. Then we implemented the Pythagoras theorem on the big triangle, the big right triangle, triangle ABC. So I copied triangle ABC in the new page and we implemented here the Pythagoras theorem. The length of side EC is 2A plus A over 2. 2A plus A over 2 is 2.5A, or we can present it also as 5 over 2A. We have only found out that EB equals to square root of 3 over 2 times A, and the hypotenuse BD equals to 2 plus 4, that is 6. We implemented the Pythagoras theorem here. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say BC square equals to EB square plus EC square. BC equals to 6, so BC square is 6 square, that is 36. That is equal to EB square. EB is equal to 3 over 2 times A, so EB square, it is actually square root of 3 over 2 times A square. That is actually 25 over 4A square. Plus, here it is actually square root of 3 over 2 times A square is 3/4 A square, and here 5 over 2 A square is 25 over 4 square, or 25 quarters times A square. 3/4 plus 25 quarters is 28 quarters. So in conclusion, we found out that 36 equals to 28 quarters of times A square. 28 over 4 is 7, so in conclusion, we found out that 36 equals to 7A square. We divided this equation number 2 by 7, and we found out that A square equals to 36 over 7. We took out of this equation number 2, and found out that A equals to 6 over square root of 7 units. Then I presented to you rule number 3. This is a triangle ABC that will be any triangle. We have the angle bisector AD. Therefore, according to rule number 3, AD square equals to AB times AC minus BD times DC. We implemented rule number 3 in triangle ABC. This is triangle ABC that they copied from the original drawing. According to rule number 3, because of the fact that AD is the angle bisector here, AD square will be equal to AB times AC minus BD times DC. So AD is X, so AD square is X square, equals to AB that is A times AC that is 2A minus BD. Here BD equals to 2 and DC equals to 4. So minus 2 times 4 is minus 8. So x squared equals to 8 times 2a is 2a squared minus 8. And we already found out that a squared equals to 36 over 7, so we substituted a squared by 36 over 7 and found out that x squared equals to 2 times 36 over 7 minus 8. 2 times 36 is 72. So we got that x squared equals to 72, and we multiplied minus 8 by 7, and then we divided by 7, and we got that minus 8 times 7 is minus 56 over 7. 72 minus 56 is 16. So in conclusion, found out that x squared equals to 16 over 7. We took out of this equation and found out that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. We finished with the first method. Then I presented to you how to find out the length of line segment X according to the second method. In the second method, we defined angle ADB is theta, therefore angle ADC must be equal to 180 degrees minus theta. Then I presented to you the law of sines. According to the law of sines, here A over sine A equals to B over sine B equals to C over sine B. We implemented the law of sines in triangle ABD. In triangle ABD, A over sine theta equals to 2 over sine 60 degrees. Then we implemented the law of sines in triangle ADC. In triangle ADC, according to the law of sines, we get that 2a over sinus 180 degrees minus theta equals to dc over sinus 60 degrees. And we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So we can substitute sinus 180 degrees minus theta in equation number 2 by sinus theta. We did it, and we got that 2a over sinus theta equals to dc over sinus 60 degrees. Then we substituted a over sinus theta by 2 over sinus 60 degrees from equation number 1, and we got that 2 times 2 over sinus 60 degrees equals to dc over sinus 60 degrees. We have sinus 60 degrees in both sides of the equation, so sinus 60 degrees will get cancelled, and we left only with two times 2 equals to dc, that is to say dc equals to 4 units, here dc equals to 4 units. This equals to 4 units. Then I presented to you the law of cosines in any triangle. Here, diagonal ABC will be any triangle. This is angle theta. The length of side AB is A, the length of side AC is B, and the length of side BC is C. Then according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We implemented the law of cosines in this triangle ABC, so I copied triangle ABC here, and we implemented the law of cosines in this triangle ABC. According to the law of cosines, we will get that cosine 120 degrees equals to a squared plus 2a squared minus bc squared, this is minus 36, over 2 times a times 2a. Cosine 120 degrees equals to minus 1 half. A squared plus a squared is 5a squared minus 36. That is equal to 2a times 2a. Here we have 2 on both sides of the equation, so 2 will get cancelled because we multiplied this equation and found out that minus 2 times a squared equals to 5a squared minus 36. We added 2a squared and also 36 simultaneously to this equation and found out that 7a squared equals to 36. We divided the equation number 3 by 7, and we found out that if a squared equals to 36 over 7, we took out of this equation number 3, and found out that a equals to 6 over square root of 7 units. Then I presented to you a new rule to find out the area of any triangle. This is triangle ABC that could be any triangle. Side AB equals to A units, side AC equals to B units itself, and angle BC equals to theta. Then the area of triangle ABC, it will be equal to A times B times sinus theta over 2. We implemented this new rule in our drawing. Here we know that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC equals to A times 2A times sinus 120 degrees over 2. A times 2A times sinus 120 degrees over 2. The area of triangle ABD equals to A times X times sinus 60 degrees over 2. A times X times sinus 60 degrees over 2. And the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. This is equal to X times 2A times sinus 60 degrees over 2. We have 2 on both sides of the equation, so 2 will get cancelled. We have A on both sides of the equation, so A will also get cancelled. And we have sinus 120 degrees equals to sinus 60 degrees. So we have on both sides of the equation sinus 60 degrees. So sinus 60 degrees will also get cancelled, and we left only with 2A that is equals to x plus 2x. That is to say 2A equals to 3x. We divided this equation by 3 and we got that x equals to 2/3 A. We have already found out that A equals to 6 over square root of 7 units, so we substituted A by 6 over square root of 7 units, and we got that x equals to 2 times 6 over 7 times square root of 7. 6 over 3 is 2, so here we found out that x equals to 2 times 2 over square root of 7 units. That is to say x equals to 4 over square root of 7 units, or in terms of numbers, x equals to 1.51 units. I will repeat again. The area, the length of side AD, that is equal to x, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay? I'll repeat it again. The area, the length of side AD, that is equal to x, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay? Thank you very much.